Hi, 8th grade. Welcome to lesson 6-2, Analyze Reflections. By the end of the lesson, I want you to be able to say, I can reflect two-dimensional figures. Let's solve and discuss it. Dale draws a triangle on a grid paper and labels it figure 1. Then, using his pencil as a guide, he draws another triangle directly on the opposite side of the pencil so that the vertical side is now 1 square to the right of the pencil instead of 1 square to the left of the pencil. He labels this triangle figure 2. How are the figures the same? How are they different? So I want to mimic the triangle. I know the bottom is 1, 2, 3, 4, 5, 6. So I'm going to draw 1, 2, 3, 4, 5, 6, and connect. So it's the same triangle, same shape, same size, but it's flipped over. It's been reflected. Think about a mirrored image, okay? Everything's the same but reflected. So similarities is it's got the same shape and the same size. The difference is it is facing the opposite way. So it has been flipped over the line. Focus on math practices. Dale draws a line in place of his pencil and folds the grid paper along the line. How do the triangles align when the grid paper is folded? Explain. Well, if we were to fold the paper, oops, that's not what I wanted. If we were to fold the paper in half where his line was, his pencil, the triangles would line up on top of each other. That is a reflection. So think about that when you're asked to draw one. Example number 1. So this recognized from last lesson. The client also wants the architect to flip the placement of the grill, putting it on the other side of the patio. Where does the client want the grill to be placed? So the architect flips the placement of the grill over the vertical line segment dividing the patio. So we divide the patio in half along this red dotted line, and we're going to reflect it. A reflection or a flip is a transformation. Remember the word transformation from last lesson? A reflection is a flip or a transformation that flips a figure over the line of reflection. Reflected figures are the same distance from the line of reflection, but on opposite sides. The grill has been reflected. The grill is the same distance from the center, but on the opposite side of the patio. The grill has the same shape, size. The orientation or the direction has changed. So we can see that it's the same distance, so there's the line of reflection. The distance from here to the old grill is the same as here to the new grill. Same grill, just flipped over. So the line of reflection is the line over which a figure is reflected. The original location and the new location of the grill are the same distance from the line of reflection. Updating the design, the architect accidentally clicked on the chair and reflected it across the center line. Draw the new location of the chair on the plan. Alright, so we see our chair. We want to reflect it. So if the chair is this far away from the line of reflection, we only go that far away on the other side, and we can draw our chair. So how do the pre-image and the image compare after a reflection? So what does it look like before and after? Well, it's the same shape and size, but it has a different orientation. Orientation is which way it's facing. Example number 2. Reflect a figure on a coordinate plane. Polygon ABCDE has vertices A at -5, 2, B at -5, 4, C at -4, 5, D at -3, 5, and E at -3, 2. Graph and label the vertices A, B, C, D and its image of A prime, B prime, C prime, D prime, E prime after a reflection across the x-axis. Okay, so the first thing you have to do is graph the points. So they did that for us. There's A, B, C, D, E, connected them all. And now they tell us they have to reflect it over the x-axis. So my x-axis is my line of reflection. So every point is going to be flipped down. So if we can see they did A and A prime, well, A is 2 units up, so A prime is just going to be 2 units down. E is 2 units up, so E prime is just going to be 2 units down. Then we see B is 1, 2, 3, 4 units up. So if we count 4 down, 1, 2, 3, 4, we put B prime there. So we can see that it's the same shape, same size, but it's flipped over on the other side. So the corresponding side lengths and angle measures remain the same, but their positions and orientations, so the way it's facing, are different. Let's try it. Quadrilateral KLMN has vertices at K is 2, 6, L is 3, 8, M is 5, 4, and N is 3, 2. It is reflected across the y-axis, resulting in quadrilateral K prime, L prime, M prime, N prime. What are the coordinates of point N? So let's use our graph to help us. And we just want to know what N prime is. So if I just graph N, that's at 3, 2. So we're going to go over 3, up 2. So it's be off the graph, but it would just be off by 1. We're reflecting it over the y-axis this time. So reflecting over the y-axis. And however far away from the y-axis that point is, 1, 2, 3, it's going to go backwards, 1, 2, 3. So our new point is at -3, 2. So that is N prime. All right, example number 3, describe a reflection. So what is a rule that describes a reflection that maps parallelogram ABCD onto parallelogram A prime, B prime, C prime, D prime? So at this point, they're giving you the two figures, the image and the pre-image, and they want to know where was it reflected? Where is the middle line? Well, if you look and draw a line right in the middle of the two figures, that line lays on the y-axis. So parallelogram A prime, B prime, C prime, D prime is the image of parallelogram ABCD after a reflection across the y-axis. Let's try it. Polygon ABCD is reflected across the line x equals -2. Graph and label the image A prime, B prime, C prime, D prime, E prime, and is measure of angle A equal to measure of angle A prime? Explain. So the first thing I want us to do is reflect it over x equals -2. X equals -2 is a straight line. That is where x is always equal to -2. So on the x-axis, there's -2, but this whole line, no matter what point we're at, every single point would have an x value of -2. So that's our reflection line. So we're just going to flip our image. Count how many spaces over. And we will label, this is C prime, B prime, A prime, E prime, D prime. Connect our points. Oops. And it's the same image, just flipped over. So is measure of angle A equal to measure of angle A? Measure of angle A prime? Yes, because it's the same size and shape. Just faces a different way, different orientation. All right, key concept. A reflection or a flip is a transformation that flips the figure across a line of reflection. The preimage and image are the same distance from the line of reflection but on opposite sides. They have the same size and shape but different orientations. So we've got transformations is the big word. It encompasses all the way we can move a shape. From transformations, we learned last class a translation. And the translation was just a slide. When we slided it around, we didn't change anything except the position. So it had the same shape, same size, same orientation, the way it was facing. The only thing that was different was the position. So different position. Now we learned about reflections. So it's another type of transformation. A reflection is a flip. So it still has the same shape, and it still has the same size, but a different orientation. So it's going to face a different way. Different orientation. And it's also in a different position. All right. Nice job, 8th grade. Let's go over and say it. I can reflect two-dimensional figures. Have a great day.